Good day, learners. Welcome to a geography discussion on map skills. Here on map skills, we're going to focus on the basic map skills that are required by geography learners for them to be able to excel in their um, tasks, in their end of term tests, and also in their final examinations. Right, we're going to touch on a number of skills, though we might not be able to exhaust all of them in one discussion. But however, we'll try to just have a look on the basic map skills and the basic calculation skills that are required in the study of geography. And this is encompassing from grade 10 until grade 12. Right. So basically, if you can check from this presentation here, ready for grade 12 MapWork exam. For you to be able to prepare for the grade 12 exam, there are basics that you must start from as early as grade 8, grade 9. That's when the step starts. You have to climb the ladder from as early as grade 8, grade 9, building up on the skills. And until you get to grade 12, you will be having a clear and complete set of understanding of the basic map skills. Right. So some of the skills that are indicated here. We have concepts of latitude, concepts of land use, concepts of map interpretation, location, landforms, slopes, orthophoto maps, map symbols, cross sections, all those things. Those are some of the basics of map work. Right. So let's go to our map skills. Right. We have here the skill of direction, which is indicated by our compass points. And also we have a skill of interpreting the flow direction of rivers. And also we have the concept of inter visibility as indicated here. We're going to try to simplify it. We have the concept of direction and bearing. We have the concept of height. All right, so we can see here intervisibility is summarized by point A to point B. Is there intervisibility between point A and point B? We're going to look at that. The point of the skill of indicating direction of flow of rivers, like we can see there, to determine where the river is flowing from and where the river is flowing towards. Then the concept of direction indicated by our compass points. And we have direction from the compass point, and also we have bearing, which is direction in terms of angles. And there we have the true bearing and the magnetic bearing as concept. We're going to look at them separately. Then we also have the skill of determining height. How do we determine height on our maps? We have contours, we have trig stations, spot heights, we have benchmarks. Those are the basic indicators or the clues of height on a map. Then we also go to map referencing. We're looking at map reference code. Each and every map has got a reference code. What does it mean? We have to look at the map reference code and also the coordinate system. When locating positions of different geographical features, we use the coordinate system. How does it operate? How do we indicate our coordinates? Right. And then we also have the skill of drawing cross sections. Right. So here we are going to look at direction. Right, basically when we're looking at direction, we are looking at the position or the location of one feature from another feature using the points of the compass. And if we can see, when we're looking at what we call the points of the compass, we have our major points here, which is the north, the west on the left, the south, and the east. Those are our major 4 points of the compass. Then on top of that, we can add the 4 additional points, like you can see those ones. Between north and west, there's northwest. Between north and east, there's northeast. And then between south and west, there's southwest. Between south and east, there's southeast. We now have the 4 major plus those 4 minor. We now have 16. We have 4 plus 4, 8. And then we can add other additional 8 between those 8 to make 8 plus 8, which is the 16 points of the compass. Between north and northeast, we have north, northeast. Between east and northeast, we have east, northeast. Between east and southeast, we have east, southeast. Between south and southeast, we have south, southeast. Between south and southwest, we have south, southwest. Between west and southwest, we have west, southwest. Between west and northwest, west, northwest. Between north and northwest, it's north, northwest. So those are the 16 points of our compass that we use to determine direction as direction of our compass points. Right. And also, if we are to determine the direction of this trig station from the given point here, it means we will just come here and draw our compass. Right, when you're drawing your compass, you draw your north-south line, which runs parallel to your lines of longitude on the map, and automatically you can add your west-east line. This is our west, and this is our east, and this is our north, and this is our south. So we are saying which direction is this from the center of our compass here. If you are to draw a line, this line is falling between south and east. So our direction is southeast as indicated here. Or if to be more precise, this direction is not cutting this angle at half. The half of this angle might go somewhere here at 45 degrees. If you are to divide that 90-degree angle, this is where we get our clear southeast. So if you are to look here, it's somewhere between south and southeast, which is south, southeast, to be more precise, which is indicated here in terms of our direction. Right. Then the other thing is also saying determine the bearing from the farmhouse to trig station number 210. Right. What you need to do there, I'll just illustrate how you use your protractor to determine the bearing of that trig station from the given point on the map, right? From the farmhouse to the trig station. If you are to draw a bearing, if you are to determine bearing, we are saying its direction, but now our direction, we are using angles. We are no longer using directions in terms of compass points, but our reference now is we are measuring an angle to determine the direction. So before I come to this illustration here, I would want to make my own illustration here on the question and indicate to you how you are supposed to use your protractor to come out with the size of the angle which is asked in the question. Right, the question is saying determine the bearing from the farmhouse to this trig station 210. So our referral point is the farmhouse, which is here. So what you need to do, you need to use your ruler to draw your north-south line on the farmhouse. Make sure when you are placing your ruler should run parallel to your lines of longitude on your map. You should never have a north-south line which is slanted. It should run parallel, meaning to say it should maintain equidistance between the line and the next line of longitude on your map, right? Because I'm not using a ruler, I will just try to be as accurate using my own free hand, and I'll assume it's a straight line going down and a straight line going up. Using your ruler, you come out with a very straight line, which is parallel to your lines of longitude on the map. I'm assuming this is my north-south line. Right. And when we're talking of bearing, we are looking at an angle measured in a clockwise direction from our true north direction. When we're talking of true bearing. So this is our true north direction. And our true north direction is the one that has got 0 degrees. We are starting from here in a clockwise direction, which means we measure our angle in a clockwise direction from the true north until we reach a line connecting the two features given. So our line should come as a straight line from the farmhouse going straight until we connect to the station here. So we are assuming I'm connecting to this red line indicated here until I reach the center of my trig station. This is my straight line connecting the farmhouse to the trig station. You will join those 2 points using your ruler. Then you take your protractor. You'll understand your protractor is a semicircle, and it has a midpoint, which is indicated there as a line at the bottom, and there is a midpoint on that line at the bottom. Then we have values on the semicircular edge of the protractor. So what you need to do, you check on your protractor, you place your 0 on the true north direction here, and your midpoint of the compass must come here, where it is corresponding to 90 on the edge of the protractor. Where there's 90, there is a indication of a midpoint. Then your 180 degrees must come here. So you're placing that line along your protractor with 180 on the south and 0 on the north, and your midpoint at the farmhouse. Your midpoint of the protractor must be exactly here on the farmhouse with corresponding value of 90 degrees here. So we are saying if you are to draw your protractor starting from 0, your edge of the protractor will come like this in a semicircle. Unfortunately, like that. This is the edge of your protractor. Your protractor is placed in such a way that the readings are on this side with 0 on the true north direction and 180 on the southern direction. So you have your readings here at the edge of your protractor, starting from 0 until you get to 90 here, and it continues from 90 until you get to 180. So what you need to do is you check the reading here, where the edge of the protractor is crossed by the line connecting the farmhouse to the trig station. The reading that you find here is the angle from here to here, which is our bearing angle. Right, that is basically how you determine your bearing from between those 2 points. Like if you can check on our protractor here, the midpoint that I was referring to of your protractor is this one, which you will place on your farmhouse. And the edge of your protractor, you can see our 0 is here on the true north according to your north-south line, and your 180 will come here on the southern part, which means this north-south line is going to run from here straight through the farmhouse at the center of your protractor and connect to 180 here. So our readings, we are using forward bearings 0, 10, 20, going like that. Our 90 degrees is here, which makes a right angle with your north-south line. If you are to draw here to join it to the farmhouse, that will make a right angle. And your reading, you will find it here on the edge of your protractor. According to this, our reading is getting 249 degrees. According to this one here, this is 150, slightly below 150, that is 149. So that is how you use your protractor to come out with the angle at the angular direction, which is our bearing. Then also there is another concept of bearing, which is magnetic bearing, which requires you to apply the concepts of magnetic declination, to apply the concept of the change in the size of the angle of declination from the given year. That one we're going to emphasize on its own, because it also requires a specific map information to be used for the calculations, right? But for the sake of this discussion, we're just illustrating how we determine a bearing, right? We move on to another concept, representation of height on topographic maps. We have clues of indications of height on topographic maps. For you to be able to figure out the shape of the landscape, you need to understand the clues of height on the map. Which clues do we use to determine height on the synoptic map? Right, like we can see here, we have contours. Contours are one indicator of height. They give us an idea of height on the map. And basically the contours, they join places of the same height on the map, which implies that whenever you see a contour line, it is joining places of the same height. Those places are equally located in terms of their altitude or height above sea level. How are our contours indicated on the map? We are having a typical part of an extract of a topographical map that we have here. Right, if you are to check here, there are some brown lines which you are seeing on the topographic map. Like, let me give you as an example, this one here, this brown line. This is a contour line. It means all these places which are joined by this line, they have got the same height. And also I will make reference of another index contour line, this one here, which is running like this. right? It goes up there and it comes down. It goes there. This is also another contour line. They are indicating places of the same height. Right. So basically, you can figure out the height by reading those contour lines. Where you find the contour lines closely pegged, like here on this part of the map, you are seeing that the contour lines are very close across this point. They are very close. Or here, you can see the contour lines across these lines. They are very close to each other. That will give you a suggestion that the area is steeply sloping. Like we are saying, if you are having contour lines and they have got specific pattern of spacing, like you can see maybe around area A, the contour lines are spaced like this around the area, right? And going in that sequence there, they are just as close to each other. They are just closely packed, right? If you are to check the nature of the landscape across this line here, it means this area is a steep sloping landscape. The contour lines are close by. They are close to each other, indicating that there is a steep gradient or the area is steep sloping. Where you see contour lines spaced like that, it means the area is steep sloping. Comparing it to area B, maybe you have the contour lines like that. If you are to check the nature of the landscape from this along this line here, you tend to find that this is a gently sloping landscape. The gradient here is gentle. The area is almost flat because the contour lines are far apart from each other. So when you are also checking on the shape of the landscape, make sure you check on the spacing of the contour lines which are indicated on that particular section of the map. And you should keep in mind that whenever you see the contour lines being as close to each other, it means that area is steep sloping. Where the contour lines are spaced further apart, that suggests the area is gently sloping. So if we check around this area here, this is steep sloping, this area is steep sloping. But if you are to check around this area here, this area from along this line, you can see one contour line is crossing the line there, the other one is here, and definitely there's nothing here going this direction. So this area is flat. Is gently sloping, but these areas are steep sloping. That is one indication of height that you can check on the map by checking the contour lines. They give you a clue of the nature of the landscape of the area by studying whether the area is gently sloping or steep sloping. Right, we also have trig stations. Right, basically what we call a trig station, we're going to make reference to the one that we are having here. Right, it's having 16 and 296.6. Let me illustrate there. Right, when you check on your trig station, it's a triangle. And then it has 2 digits. Maybe it's having 16 and having maybe 302 1.6, those 2 digits. Right, if you check your triangle with those 2 digits, this is what we call a trig station, a trigonometrical station. And these two numbers, they have got 2 different geographical meanings. One, this number here, the whole number, is the station number. There is a point in time when you are supposed to make reference to the numbers on the trig station. Maybe the question will be saying, what is the height of the trig station indicated in block B2? You get confused to know which one is the height, which one is the trig station. The whole number is a trig station, and the decimal is the height of that particular station. And mind you, there is no way you can confuse a height of 3021.6 with 16 meters. These are 2 different numbers which have got so wide a variance between them. If you check around the contour lines and you see maybe there's a contour line indicated 3000. How can you say an area, this station is indicating 16 meters when the contour line around there is 3000? That doesn't make sense. So you give the height by the decimal, and the 16 in that instance will be a station number. So know which number to use if you are making reference to a trig station. There is always a station number and the height of that particular place as indicated on the trigonometrical station. So that is another indicator of height. You check on the spot on the trig stations. If you want to figure out the shape of the landscape around that area, they can give you a clue of the height on that particular part of the map. Right, and we also go to spot heights. A typical spot height which is indicated, right, if we check here, we have this one in red, which is 10,204. That is typical of a trig spot height. A spot height, we just have a dot, and along that dot, there is a written number. This number here is the height of that spot height. So in this instance, 204 is for 204 meters above sea level. That is the height of this given trig station, spot height, which is this dot here. Then we also have benchmarks. Benchmarks, usually they are along the roads. It's a point along the road whose height is specifically known. Like if we check here, we have 21.1. There is this sign here, and then maybe it's along the road. The road goes like that. This is a benchmark. So the benchmark there, it means the height. The benchmark along the national route N2, the height is 21.1, which means the height of the road on that particular point is at 21.1. Right. That is a benchmark. So basically, these are some of the indicators of height that you should keep in mind when you are dealing with height on the map. Always remember, we have those indicators of height on the map. Make reference to them, or sometimes you have to use them to calculate gradient between given points, or you have to use them to determine the flow direction of a river or whatever. Those are the indicators of height that you must keep in mind whenever we are looking at the maps or topographic maps. Right, then we go to map referencing. Right, I will make an example of map referencing here before I come to this side and indicate or show you what is happening here. Right, I will use the reference 3318 DB PAL. Right, I will go to my indication. Right, I will copy my reference as 3318 DB. 3318 DB. Our reference is 3318 DB PAL. Right, I will try to quickly explain on the meaning of that reference and how we come out with that reference in geography. This is a reference of a particular map from South Africa, 3318 DB. Right, I will start by indicating these first two digits here. The 33, what does it mean? It means 33 degrees latitude. And this 18, what does it mean? It means 18 degrees. This is 33 degrees to the south latitude. Always remember, when we are indicating, we also indicate the direction when we're giving coordinates. It's 33 degrees to the south, which is for latitude. And 33 degrees to the south from latitude. And then we come to our 18. Our 18 is for east, 18 degrees to the east, which is representing longitude. And then we come to our D. What does it mean? D is for bigger block subdivision. And then our B is the smaller block subdivision. Right. Then our PAL, this is the main settlement occupied by the map. So basically, that's the meaning of that 3318 DB PAL. It means 33 is representing 33 degrees to the south of latitude, and 18, it means it's representing 18 degrees to the east of longitude. Then our D is representing the bigger block subdivision of the area which is mapped, and our last digit, which is B, is representing the smaller block subdivision of our division of the mapped area. Then PAL is the main settlement for that instance. Right, let me just go on and elaborate on our map referencing, right, what it means. Right, we are saying when we are drawing maps, we draw maps according to lines of latitude and lines of longitude. Right, so what are we saying? From extraction of our globe, we have lines of latitude, which are drawn on the globe, and our lines of longitude, which are also drawn on the globe. Right, I'll make reference to this block, though it's not very straight. I will assume this is my line of latitude, which is 18 degrees to the south. And it means if I am to get to the next line of latitude plus 1 degree, I'll go to the next line, which is 19 degrees to the south. Remember, we are in the southern hemisphere. Our values, they increase going towards the south. That is why we are naming them south. We're in the southern hemisphere. Our values of latitude, they increase going towards the south. Right, then we come to our lines of longitude. Right, sorry for this one. I was supposed to start with latitude. I was supposed to put my 33. If you are to use this example here, let me use the example that we have to illustrate the map referencing. We're having 33 for latitude, and which means we are supposed to have our 33 as the first line, and the next line is going to be 34 degrees to the south. Then we go to our longitude. Our line of longitude is 18 degrees to the east, and which means our next line of longitude to come in plus 1 degree is going to be 19 degrees to the east. That's our block from which we get our map 3318 dB PAL. Right, what it means here, if you are checking on our blocks, you can see that our coordinates, we are picking them from this particular intersection here of latitude and longitude. And remember, when we are referencing, we start with latitude. We pick our value from the northwest corner. So, which means the reference in degrees for this block, we pick our reference from the northwest corner. Our intersection on the northwest corner is between a line of latitude of 33 and a line of longitude of 18. That is where we get our reference for this particular block here. So we are saying our map was extracted, the mapped area was extracted from this block between the line of 33 degrees south of latitude to 34, and between 18 degrees lines of longitude to the east and 19 degrees to the east line of longitude. Right, so we are saying this area here is an extraction from the globe. This is too big an area to be drawn on the size of our A3 maps with the scale of 1:50,000. This mapped area here, if you are to take from 33 degrees to 34 degrees south and 18 to 19, this area is too wide. You cannot draw it on that size of the maps which we can use and which we can effectively use when we are doing geography. So we have to subdivide this block into smaller blocks which can be mapped and which can fit on that size of paper available at a scale where we can be able to study. Remember, if we keep on reducing the scale, we reduce it from 1:50,000 maybe to 1:1 million, we end up leaving a lot of information which is of geographical importance, which we want to study. We'll end up neglecting all those smaller features, such that we'll end up having a very small scale map with very little detail. Yes, we are covering a wide area, but we are not worried about the area covered. We are worried about the details in the area which is mapped. So what we want is we need to have a larger scale map, which is more friendly towards the study of geography, and where we can see the features, where we can relate our features to whatever geographical aspect is in study for that particular time in space. So we need to have a bigger scale such that we are able to see the features and be able to interpret them. So given a scale of 1:50,000, we need to subdivide this. We will subdivide it into half. This block here is cut into half and is also cut into half. We will see now here that we have 4 subdivisions from the same old block. Our block initially was 1, but now because of subdivisions, we now have small we now have 4 blocks. And these blocks, how do we name them? We name them in this sequence alphabetically: A, B, C, and D. That is how we name our blocks according to the alphabet and in that sequence. Right, so we are saying we have block A from the old block and block B, C, D from the old block. But however, we are saying still block A is still too wide, it's too big to be mapped on one piece of map and be drawn into the scale of 1:50,000. The area is still too wide. We need to subdivide it. So we target block A, we subdivide it again into 4 equal blocks. My assumption here is those blocks are equal. We subdivide them along this is along between 180 to 90. They are 60-minute lines. We subdivide it along the 30-minute, and also we subdivide along the 30-minute here. And then we come to our block now. We are now subdividing it along the 15 and also along the 15-minute line here, such that we end up having 4 blocks in the old block A. And again, we do the same in B. We end up having 4 blocks. We do it with C, we subdivide C, and we do it with D, we subdivide D. So we come back to our reference. We have the first letter here. The first letter is representing one of these 4 bigger blocks. When we subdivide the original block, we have A, B, C, and D. So it means for this reference, our bigger block is D, which means our mapped area automatically is coming from this block here. Right, and again, we name these ones, the smaller blocks, according to the sequence of the first block, the first letter first, then we name them according to the same alphabetical distribution that we used for the 4 bigger blocks, which means here we are starting with A, and this is A. We start with A, this becomes AB, this becomes A, C, and this becomes A, D. We are using the same sequence of A, B, C, D, like what we did in the bigger blocks, A, B, C, D. We come to this one. This starts with B, the bigger letter, B, A, and this one becomes B, B. This one becomes B, C. This one becomes B, D. Then this one is letter C. It becomes C, A. It becomes C, B. This becomes C, C, and this becomes C, D. We come to this one. The bigger block is D, D, A, D, B, D, C, and D, D. This is a D. Right. So what are we saying? These are our subdivisions of those blocks. So when we are talking of 3318 DB, it means the mapped area is under bigger block D and smaller block B, which means our mapped area is this particular section here. This is where we extract a map with a reference of 33 degrees to the south, 18 degrees to the east, according to the northwest corner of the block. And the bigger block subdivision is B, and the smaller block is D. Bigger block and smaller block is B. This is where we're getting our DB. And if we check the main settlement, which is occupied by this area, is Paarl. That is our map reference. So that is where we get our map reference, and that is how we reference our maps. So typical questions that you are going to get based on this illustration here. The question can say, give the map reference of the map to the north of the given map reference 3318 DB. Automatically, you know your north is there. This becomes 3318 bigger block B, smaller block D. That is the reference of this. Or if the question says, give the reference of the map to the southwest. Southwest is here. What is the reference of this map? Is 3318 DC. Those are the typical questions that you can get on map referencing, right? I think with what I've explained here, this is the same as what is illustrated here, according to the illustration of that particular example. Right, so we are done with map referencing. We move on to the coordinates. The coordinates, what we need to do with coordinate system for us to locate exact positions, we need to do some calculations. And basically, I will summarize how we pick our coordinates from the given map information. Right. What you need to know when you are reading your topographic maps, when you are asked to calculate the exact position, they already have degrees and minutes provided for you. What you only need to add there is to add the second line and get the corresponding values for seconds, second value for latitude south, and minute and second value for longitude to the east. That is only what you're supposed to calculate. If you get a question that requires you to locate the exact position of a given feature on the map, the degree values and the minute values will already be provided, and what you only need to determine is the second value. And what you should always remember is, for 1 degree, there are 60 minutes, which means from 1 degree, if it's 26 degrees, for you to get to the next line of 27 degrees, there must be 60-minute lines. And those lines are the ones that are on your topographic maps. They will be indicated there. They won't be 60 of them, but maybe they will be covering a quarter of the number of minute lines. And then we'll be having also for longitude, your minute values for longitude will be provided on the map. So what you need to do there is just to calculate and estimate the second values for the given map information. Right, that is with determining the coordinate system using that particular given map information. And also remember, 1 minute is equal to 60 seconds. So which means from 1 minute line to the next minute line, you have to make subdivisions of 60 and be able to determine where to get the corresponding values of seconds for latitude and seconds for longitude. Right. We move on to inter visibility as another map skill. Inter visibility, we are saying, are you able to see a particular point from a given point, given the shape of the landscape? Right. The question here is saying, on this example that we are having, we want to determine if there is inter visibility between the Nance Dam and the Pearl Rock. Like here, as indicated, the Nance Dam is here, and the Pearl Rock is indicated at this particular station here. So if you are to check the cross-section of the area between the Nance Dam and the Pearl Rock, it shows something like this. If you are to take those values and try to draw a cross-section, you will see that this is the nature of the landscape. If you are to take a side view, if you are to draw a cross-section, our Pearl Rock is standing at 180 meters. And our Nance Dam is at 600 meters above sea level. But in between here, there is this Gordon's Rock, which is indicated here in between, which is a rocky area, which is a high-lying area at 654 meters, according to this height, which is indicated around the mid of our line. So what you do when you are drawing or when you are trying to determine if there's inter visibility between two given points, what you need to do is you draw a straight line joining those 2 points, and you check the height of your point of start and the height of your point of end, and check the heights which are crossing your straight line between those 2 points. Like what is indicated here, our height is stretching from Nance Dam and is going to the Pearl Rock, like this red line here. But in between there is an outcrop, a rock outcrop, which is at 654. So Pearl Rock is not visible from the dam. We cannot filter through if you are at this height of 600 meters, and then there's an outstanding feature which is high lying above the height of the dam and the height of the Pearl Rock here. Automatically, it means Pearl Rock cannot be seen from the dam. Pearl Rock cannot be seen from the dam in this instance because there is a high-lying feature. So now that takes us back to the concept of determining height on the map. Check on the clues of height between the 2 points along your line. If there is any indicator of height which is higher than your points, it means there is no inter visibility because there is what we call an obstruction. This one here is what we call an obstruction. It obstructs sight of Pearl Rock from the dam. We cannot see because this feature is highlighting. It acts as an obstruction. And then if we are to determine is there intervisibility between the school, which is at 180 meters, and Pearl Rock, which is at 540 at 3.1 meters. Definitely, if you are to draw the cross section, you can see that the area is flat. Let's look at the school from the map. The school is here. The height at the school is 180 meters above sea level. And if we check across, this is our Pearl Rock standing at 543.1. So if we draw a straight line here indicated by the dotted blue line, if we try to check the heights crossing this, all these heights, they are not exceeding 543.1, which is the height of our Pearl Rock here. There is a height of 200 meters indicated here, which is less than 543. And also there is a height of 300 meters here. There's a height of 400 meters here. All these heights, they are not up to 543, which means there is no obstruction between the school and the Pearl Rock, like what is indicated here by this line. You can see that there is nothing which is obstructing. There is no feature which is reaching this line of sight between the school and the Pearl Rock. Unless maybe if there was a feature like this. This will now be an obstruction. But if you are seeing the nature of the landscape is basically flat, gently sloping landscape from the school, sloping gently upwards going to Pearl Rock. And there's nothing which is obstructing the line of sight between the school and the Pearl Rock. So definitely Pearl Rock is visible from the school. There is intervisibility between Pearl Rock and the school. Why? Because there is no obstruction, or there's no obstructing feature between the two points, as we can see from the illustration of the cross section of those two points as indicated. Right. So this is another illustration of Fernandez Dam. This is now in terms of the image. The Gordon's Rock is there, and Pearl Rock is somewhere after the Gordon's Rock. So this guy here cannot see the Pearl Rock, which is somewhere behind the Gordon's Rock and is not even the height of Gordon's Rock. So this Gordon's Rock is an obstruction. You cannot see the Pearl Rock from this dam because the Gordon's Rock is much higher at 654 meters, way above the height of Pearl Rock, which is behind it. That's the visual illustration of intervisibility. Then we move on. I want to look at river flow direction. How do we determine the flow direction of a river? That is a very critical and important aspect in geography that we must always master to determine the flow direction of the river. Right, one indication here is what we are seeing here. Flows from land towards the sea. If you see there is a river, and unfortunately enough, maybe the map is covering the sea area, automatically there's no way a river can start from the sea going to land. That is geographical misalignment, or can we say it's a non-existent geographical fact, or can we say that is the worst geographical misinformation? There will never be a situation where you find the sea draining out onto land. It's obvious when you see a river which is feeding into the sea, automatically that is the flow direction. The river flows from the land feeding into the sea. It's one indication. And the other indication, you check the contour lines which are crossing the river to determine which one is the high-lying area and which one is the low-lying area. Like here, the indication is this contour line is 80, and this one is 60, and this one is 40. Automatically, there's no way the river can start from 40 here, opposing gradient going up the slope. Unless in geography, when we are talking of drainage fish systems which are not related to the outlying geographical features. When we talk of antecedents drainage, that is in grade 12, and when we talk of superimposed drainage. Those two, that's where we can find that the drainage system can at some point oppose the outlying geographical landscape. But that is not always the case, and that is not always everywhere. That is a special case of geography when we talk of antecedents and superimposition. Right. So generally, we are saying rivers flow from high to low. So if you check your contour lines which are crossing the river, you also tend to find that where there is higher height, that is where the river is starting from and going towards low-lying areas as the value of the contour lines decline or decrease. Right, that is indication number 2. Then indication number 3, we look at the contours points. Where are they pointing? They always point upstream. I want to illustrate this geographical sense because learners in most instances, they tend to memorize that contour lines point upslope. Why do they point upslope of the stream? That's the question. And I have tried to figure out sense from most of the learners. They will fail to give a justified geographical reason as to why the contour lines will always point upstream when they are crossing a river or when they are crossing a stream. Right, let me try to illustrate and give you the justification of why the contour lines will point upstream. Right, I will go to my illustration board here and try to make some illustration. Right, I'll give this illustration. This is our general ground, and we are going into the river channel like this, and this we're back on the ground surface. This is our river channel. The river is flowing in this channel here, and let's assume maybe our stream has got the discharge at that particular point. Right, I want to make it a 3-dimensional. Right, the same landscape is stretching like this, and our same stream is here. It's going down. The landscape continues like that. I'm trying to illustrate a 3-dimensional so that my point at least maybe becomes clear somehow, or you can get to understand what I'm trying to point across. Right. So what am I saying here? I'm saying this is basically the shape of my landscape. This being the ordinary ground, and this being the stream. So we are saying our stream is continuing like this. Our stream is continuing like this. This is the channel where the water is flowing, going down the slope. And let me put the other dimension here to emphasize what I want to highlight. Right. Our stream is like this. Right. This is our landscape, how it looks like this. Right. So we are saying we're having a stream which is flowing here. Right. It's sloping downwards, going into the stream. Our ground level is basically flat. Right. Our stream is flowing there. Right. Let me give you as an example. We are having a contour line. We're having a specific height here. This is a contour line. It's a flat landscape. The same contour line, the same height is maintained here. Let me say my height of this contour line is 100 meters. And again, after it crosses the river, it's again at the same height of 100 meters. We said contour lines, they join places with the same altitude, or we are saying they join places with the same height. If this is 100 meters and we are on an ordinary ground surface, and we want to get into a stream, we know well that the river stream will have a lower altitude or lower height compared to the ordinary ground surface. Because of the action of the river is going to erode. The river will erode vertically, deepening the river channel, meaning to say the height within the channel will be lower than the height of the ordinary ground surface adjacent to the river. If this is the flood plain of the river, The floodplain is elevated compared to the river channel. The river channel is eroded by river processes and of erosion, and basically it's lower. If you check here, this is the base of our river channel, and also this is the base of our river channel. We can't compare this to this, and we also can't compare this height to this height. This is definitely a lower height, and the river is flowing downstream going in this direction. This is our direction of flow of our river. It's coming from that end, going that other end. So if this is 100 meters at this point and this is 100 meters at this point, we want this contour line to still join places of the same height through the river channel. Where are we going to get 100 meters in this deepened channel? Automatically, we cannot draw this line connecting into the river stream and joining here, because this height cannot be 100 meters because it's a lower height because of the erosional processes which are caused by the river. So for us to get a corresponding height to 100 meters, which is like this, we will get it up the stream. 100-meter height, maybe we're going to get it somewhere here, very far away from this line here. Our 100 meters on the floodplain is at this point and at this point. But in the river channel, we cannot get it adjacent to the floodplain here. But we'll get it somewhere up the stream. So which means if we are to connect this contour line, it has to join going up and get into this point where we get to 100. And again, gradually it will get to connect along the banks of the river until it connects here. So that's the sense. This contour line now is going to have this shape. It's going to go up the stream and it's going to connect until it gets here. So if we check now, if this is the situation, how are the contour lines going to appear as they cross the river on the map? If the height is here, the same height cannot be maintained here across the stream. We get it somewhere up the stream and we go back and connect. If the height is here, we cannot get it up. We cannot get it adjacent here. We get it up. The contour line goes back like this. And the same happens. That is why we say, if you find these contour lines pointing this direction, it means the river is going in that direction. Our contour lines, they point upstream for that essence. And we end up having a sequence of contour lines that will point upstream of the channel of the stream or the river for that reason. That is why we say our contour lines, they point upstream. So whenever you see contour lines crossing a river and they are pointing towards the direction, they are pointing towards where the river is coming from or the stream is coming from and opposing where it is going. Right, that's the idea behind that indication of contour lines pointing upstream. Then also you check on the tributaries. The tributaries, mainly our drainage pattern is dendritic in most areas, and we tend to find that the tributaries, they join at acute angles and they join downstream. So our acute angle in this instance is on this part here. This is the acute angle. So it means the stream is going in that direction. There is no way a river can start as one and end up developing what we call distributaries like this. We cannot say this river is going in that direction. That can only happen when we reach the mouth of the river and the river is discharging into the sea or into the ocean. That is where we tend to find distributaries. But a normal river over the land surface will have tributaries joining at acute angles, and the direction of flow will be the opposite of the acute angles in that sequence as indicated there. Right, the other indication is that of when there's a dam. For us to figure out where the stream is going, we check the dam wall and where the water is accumulating. Definitely water accumulates before the dam wall. The dam wall will act as a blockade to the flow of water, and the flow and the water will accumulate upstream. Meaning to say, if there's a dam wall here, and water is accumulating like this, automatically the river is coming from this direction because the wall is blocking the water and the water is accumulating going up the stream because it has been blocked here. And the river or the stream continues after the wall. There is no way water can accumulate after the dam wall. That doesn't make geographical sense. the water accumulates before the dam wall. So when you see the dam wall and the water accumulating on that side, it means that is where the river is coming from. I think that makes geographical sense. Right. So we move on. That is with river flow direction, how we determine a river flow direction. We make use of those indications and try to justify the direction of flow of the river using those clues indicated. Clue of the flow direction of the sea, if you are fortunate enough to happen to have a map which has got a coverage of the sea area, the moment you see the river getting into the sea, automatically that means the river is flowing in that direction of the sea. And also where you see the contour lines decreasing in height, it automatically means it's from high area to low lying area. That is where the river is flowing towards. And also you check the contours are pointing upstream for the reason given. And also you check how the tributaries join the mainstream at acute angles. It means the opposite side of the acute angle is where the river will be flowing towards. And then also using the argument of the dam wall, that will basically give you a clue of how the river is flowing in terms of the direction of flow of the river. Right, we come to the indication of flow direction of the river. In what direction does the Stellenbosch River flow? Right, if you can check there, the direction of flow of that particular river from the extract of the topographic map. Definitely, this Stellenbosch River, if you can check where it is coming from and where it is going, it's coming from around here, it goes like that, it goes like that. The justifications there, they are there to indicate to us where the river is going. One justification which is clear, the sea is here. The river cannot flow from the sea getting inland, but rather it's flowing from inland getting to the sea. There is one justification which is clear there. If you are to use an extract from the map and try to justify the flow direction of that river. And then, if you are also checking on the tributaries, there is one tributary that we are seeing here, which is joining there. The acute angle is this direction. We say the river will flow in the direction opposite the acute angle. So automatically this river is going in that direction because our acute angle is facing this side and the river must be going in the opposite direction. And also the clues of height. We are given the height of this particular point is 100 meters above sea level and the height of this particular point is 300 meters. And given the justification of the flow direction of a river from a high-lying area to a low-lying area, automatically we can justify that the river is flowing from the 300 mark to the 100 mark going to the sea. It's clear if you are figuring it out from the topographic map, you can easily relate to that. And also, if you are to check the bending of the contour lines which are crossing the river, if we check around this area, we are seeing the contour lines are like this. Around this area, the contour lines like that. And also, wherever we are seeing, like somewhere here, the contour lines, they are pointing upstream. Like what we have indicated earlier on, where you see the contour lines pointing upstream, that is a suggestion that the river is going in the opposite direction. The contour lines will point upstream and the river will be going the other direction. And there is another indication here, which is also crucial and which is also very important as an indication of height. There's a dam wall here, right? If we see, this is the wall. Right, this stream is going in that direction. Water is accumulating on this side of the wall, meaning to say this is a continuing stream from the dam wall. So there's no way this river can cross the dam wall and feed water on the other side of the dam wall. That is geographical irregularity or geographical misinformation. Right. So automatically, because of the existence of the dam wall here and water accumulating on this side, it automatically means there is the stream which is feeding into the dam, and this stream is continuing after the dam wall, going in that direction and ultimately feeding into the sea. Right. So basically, if we are to check from the topographic map extract, we can actually relate the information that we had discussed earlier on. We can easily relate it to the given map information, and we can safely conclude that the river flow direction is easily determinable given the fact that we are using the substance evidence that we have gathered from the theoretical part of our study, and ultimately applying it to the given map information. So to sum up, we have in this discussion touched on some basic skills in geography, which are equally important and which you must embrace in every in every part of your study of geography, so that you make use of them and you apply those skills to help you to interpret maps correctly, and also to be able to figure out what is happening at each and every geographical space. That was our discussion for our map skills. And these skills, basically, I think they are equally helpful for the whole spectrum of the study of geography from grade 10, even from grade 8, grade 9, from grade 7, 8, 9, the senior phase. We can also make use of these skills, though it's the basics of map work, but some of the skills like the flow direction of rivers, they are applicable to the senior phase. And also the indications of height, direction, bearing, those are very crucial, very critical for the senior phase. And for the sake of building up on those skills, they need to be built from an early age of study of geography, from social science. They need to be built skill after skill, and they need to be enhanced in the study of geography. They need to be applied, so that you will tend to find that when you get to your final examinations in matric, the application of those skills will be just at the disposal of your fingertips, and will ultimately help you in attaining the best grades in geography. That is basically what you should embrace in the study of geography. You have the basic skills. You have the basic map reading skills. You have the basic map skills, which will enable you to be able to interpret maps in the correct way and be able to interpret the given map information in the right way. Right. So that brings us basically to the end of this discussion. I hope we are going to meet in other discussions. We are going to have a variety of other map skills, map calculations. We are going to do quite a number of those map work aspects, like map interpretation, relating maps to the given theoretical part, relating maps to paper 2 concepts, relating maps to paper 1 concepts, and also basic map calculations, calculation of magnetic bearing, the calculations of aspects like gradient, calculation of distance, the calculations of all those are geographical. When we're drawing cross sections, we calculate vertical exaggeration, right? All those aspects, we're going to do them in other discussions, and also try to illustrate in as much as is possible, and to simplify those concepts for the benefit of each and every geographer, for the better understanding of those calculations, and or for the better understanding of those concepts for every geographer across the board, so that a geography becomes one of the easiest and most passable subjects. All right, that brings me to the end of this discussion. Your host, as usual, Conrad Mopinguri. Thank you.